In this problem, we're asked to find dy dx, where x and y are related through this equation. 2xy plus 3x squared is equal to y squared plus xy cubed. Now, this is an implicit differentiation problem because although x and y are related, it may be very difficult to solve for y in terms of x. And in fact, y may not be a function of x except for explicit values of x and y. So let's go ahead and take the derivative with respect to x on both sides of the equation, bearing in mind that when we differentiate a product, we have to treat the x's and y's differently. Whenever you differentiate a y, you have to use the chain rule and multiply by dy dx because y is implicitly a function of x. So let's see what we get. First, let's differentiate the 2xy. We'll differentiate 2x and we get 2. Leave the y alone. Then we'll leave the 2x alone and differentiate y, and we get 1 times dy dx. 3x squared, that does not involve any y's, so we simply get 6x. And what about the right side? Well, when we differentiate y squared, we get 2y, but again, using the chain rule, there'll be a dy dx. And here we have to use the product rule again. Differentiate the x and you get a 1. Leave the y cubed alone. Plus, now let's leave the x alone, there it is, and differentiate the y cubed, and we get 3y squared, and again, dy dx. Since we want to find dy dx, our goal is going to be to put all the terms involving y, dy dx, on one side of the equation and everything else on the other side. So let's see what that looks like. We have 2xy dy dx minus 2y dy dx minus 3xy squared dy dx is equal to, and put everything else on the right side, y cubed minus 2y minus 6x. Now we can factor out the dy dx, and we get 2x minus 2y minus 3xy squared times dy dx is equal to y cubed minus 2y minus 6x. And now dividing both sides by 2x minus 2y minus 3xy squared, we get the answer dy dx is equal to y cubed minus 2y minus 6x over 2x minus 2y minus 3xy squared, and that is the answer to our problem.